Hi. So today let's discuss the indirect utility function. Okay, so the definition for this indirect utility function is that let's say for each p and w, okay, so those are vectors, right? So if we have a positive p and w, then we simply denote the value of the utility from some utility maximization problem by this v. Okay, so v and taking this p and w as these parameters, and v will be a real number. So this v pw that'll be called as this indirect utility function. Okay, so so this v is just the utility function u, and taking this variable x just simply as this solution x star. Okay, solved from this UMP. Okay, so now let's discuss some properties, okay, that might be useful in later studies. So this will be the proposition of 3.d.3. So let's suppose if the utility function u is continuous and it is for a locally non-saturated preference relation, which is defined on the R plus L dimensions, then this indirect utility function, it has basically four important properties. So the first one, we have already seen this general properties previously, and this is called homogeneity of degree zero. Okay, and this looks very easy to prove. And the second one will be strictly increasing in W and non-increasing in the price PL for any L, commodity L. Okay, and the third one is called quasi-convexity. Okay, so quasi-convexity is just the opposite of quasi-concavity. Okay, so remember that when we talk about quasi-concavity, so we simply have the upper contour set to be convex. Okay, so the quasi-convexity simply requires that the lower contour set to be convex. Okay, so here we're talking about the quasi-convexity for this function v, indirect function. Okay, so this would be asking that the lower contour set of the set of this p and w, this set is a convex set. Okay, for any level of this v bar. Okay, and lastly, it is also continuous in p and w. Okay, good. So let's try to prove this. So the first, for the homogeneity of degree zero, so this would be very straightforward and similar to the proof previously. So for any alpha, a positive number, so we already showed that the homogeneity of degree zero for x as the solution, right? So if we multiply alpha, then this doesn't change the solution x to this problem. So this means that for any x star in this solution set multiplied by alpha, okay, then it is also true that this x star is also in the problem in the solution set of x without alpha. Okay, so as given above. So this means that the interactivity, okay, from the alpha p and alpha w, this gives the utility of x star, and it is also that v of pw, this also gives you x star. Okay, so those two, they have to be the same. Okay, good. So that would be the homogeneity of degree zero. Okay, and so the second one that we're gonna prove is the strictly increasing in W and non-increasing in the price. Okay, so let's do the price first. And for any commodity, okay, L, let's suppose PL prime is bigger than PL. Okay, so now let's compare the following two utility maximization problems. So those two, the consumer is choosing the X to maximize the utilities, but only different in the constraints. So in the first one here, we have this PL as the price for L. And in the second, we have the PL prime, which is bigger than PL, and nothing else. Okay, so the else will be all the same. So because we have this PL, this prime, this price bigger than PL, okay, so this means that the first solution set, the first set of X, in the first UMP, this has to contain more feasible choices than the second one. Okay. So this means that when this consumer is facing more possible choices in the first problem, and that which is containing more possible choices for this consumer than the second one, in this case, the first problem must yield a weakly higher utility or indirect utility here in this case. Okay, that's why we have this this relationship here. Okay, good. So that would be the for the price. And how about for the wealth, for W? So for W, let's suppose, okay, suppose that we have two different W's, so which is W prime is bigger than W. So from the War's law, so it means that the consumer spend all the money, and for any X, and this we have this as the War's law, and which this W is less than W prime by just the assumption that we gave. And then we know that there must exist some small number epsilon, okay, because we have a gap here, okay, so such that for any, let's say, some solution Y, and in the neighborhood of X within the radius of epsilon ball, so we must have this P inner product Y. This is also feasible. Okay, so this Y is also feasible. So P inner product Y, this is smaller or equal to W prime. So, and then we're gonna use the local non-satiation. Okay, then there must exist some, let's say this would be just some notation. Okay, so some X prime that is in this epsilon ball of X. There be some other solution that is strictly preferred than X itself. Okay, so therefore we must know that for any X double prime, okay, which is denoted as the solution to this problem with price P and wealth W prime, then we must have that this X double prime is strictly preferred to X. So in other words, in the language of utilities, so from this strictly preference, then we must derive this greater sign, right? So in this case, we have this utility of X double prime, which is strictly greater than utility of X, and this UX double prime, this has to be exactly the VPW prime, and UX has to be VPW. Okay, then we obtain that this under this W prime, then this indirect utility has to be strictly greater than the other one. Okay, good. So now we have shown the first two properties, right? So about the third one will be the quasi-convexity, okay, regarding the indirect utility and with respect to P and W, okay. And we have said that the quasi-convexity will simply require that the lower contour set to be convex in P and W, okay. So we simply, we just want to construct a convex combination and to show that that combination is also in this set. Okay, so that will be the proof for this part. Okay, so how do we do that? So for any level V bar and any number alpha between 0 and 1, let's just give to any of those 2 points. Okay, so which is already in the set, and this will be our starting point. So what we are gonna show is that their convex combination of those 2 points, this is still in this set. Okay, so if we can show that, then we have proved this convexity of this set. Therefore, the quasi-convexity for the convexity for the lower contour set. Therefore, the quasi-convexity for this indirect utility regarding the P and W. Okay, so how do we do that? So you want to show their convex combination is also in that set. Okay, so which is just, this would be just a restatement of the language we just said, right? So this is just in the mathematical expression. So this is the after the convex combinations, right? We have alpha p and 1 minus alpha p prime, and also the same thing for w's. Okay, so from here, and we know that, so for any x, okay, such that the alpha p plus 1 minus alpha p prime inner product with x, which is smaller or less or equal to alpha w plus 1 minus alpha w prime. So this inequality here, this simply means that this x, it has to be a valid solution, okay? And in other words, this cannot exceed the budget constraint in this case, no matter what is this constraint is, right? So here, it's simply by stating this inequality, we are just looking at this x, right? So we want to make sure that the solution x here, it is valid or it is feasible. Okay, so that's it. Good. So how do we make sure that this x is feasible? Okay, so now let's just expand this and check under what conditions this inequality will be satisfied, right? So that's the thing that we're gonna do here. So let's simply expand the left hand side, and which is alpha p inner product x and 1 minus alpha p prime inner product with x, and the right hand side will be similar. Okay, expanded here. So given those terms, then it has to be the following cases. Okay, so it has to be either this term is smaller than or equal to this, or this is smaller than or equal to this, or both of those two cases just mentioned. Okay, so if the first case, then this is true, right? So it means that the utility of x, this is smaller than or equal to the indirect utility of p and w. Okay, that's simply a reinterpretation of this, right? And in the second case, we have that under p prime and w prime. So this utility of x, this is still so this bundle x, it still satisfies the utility such that this is less than or equal to this indirect utility given the p prime and w prime. Okay, or both, right? And we can see that no matter which is satisfied, which is true, or both, we always have that this v of pw or v of p prime w prime, those two, they're always smaller or equal to v bar. This is the starting point, right? Remember that we simply select any of those 2 points. So those 2 points with the pw and p prime w prime, those 2 points, they have to be in this lower contour set, right? So, and we can see that because this and this, those two, they are less or equal to v bar. So this means that the left hand side, the ux, under any of those cases above ux, this has to be less than or equal to v bar. Okay, so now we have shown that in any case of those inequalities, we have to have that this after the convex combination, then this point, it is still satisfying the condition, or it means that this this P and W, it is this collection of those P and W. This also satisfies the indirect utility. It has to be also less than or equal to the V bar. Okay, good. So those would be the third property about quasi-convexity of the indirect utility. So the last one would be something about the continuity. Okay, so we said that this V of P and W, this has to be continuous in P and W. Okay, so here we're not going to show the full proof for that, and we simply address some important points as mentioned on the textbook. And if you're interested, then you could have a further thinking on this. Okay, so given the convexity of the preference relation, okay, so the continuity of this indirect utility, it simply follows from the facts that first, that this x, P and W, it is continuous. Also this ux, it is continuous. Okay, so those are proved previously, given the properties in the preference relations. And then we know that this v will be just a compound function of u and x. Okay, so this v, it has to be continuous in the P and W. Okay, so this would be a rough idea or rough sketch of the proof for this part. Okay, and you might want to have a further look on the textbook for more detailed proof for this. Okay, good. So, and then in this episode, we extensively discussed multiple properties or comparative statics, or basically properties, right? The fundamental properties that we might use in the indirect utility functions. Okay, and those will be quite useful for us to further study either the utilities or the related problems with it. Okay, good.